Hello everyone. On this video we will be going over the properties of our definite integrals. Okay, so our first property is the integral from a to that same value a of f of x with respect to x is equal to 0. Okay, so normally you'll have an integral from like 2 to 4 or -3 to 7 or something like that. But if you start and stop at the same point, at the same value a, then your integral, or in this case your area, would be 0. Okay, so now our second property is when you have the integral from a to b of some function of x with respect to x, that's going to equal the negative, and you just flip those around. So instead of from a to b, we have from b to a of f of x with respect to x. Okay, so now our third property is going to seem a little bit, I guess you could say, expected, but we're going to go over it anyway. The integral from a to b of some function of x, either plus or minus, same thing, well, same property, g of x with respect to x, you're going to distribute that integral, is equal to the integral from a to b of f of x with respect to x, and either plus or minus the integral from a to b of g of x with respect to x. Okay, now our fourth property, again, is going to seem to go as you would expect it to go, but we're going to go over it anyway. If you have the integral from a to b of some constant times f of x with respect to x, then that's going to equal, we're just going to get our constant and we can move it right out to the front. That constant times the integral from a to b of f of x with respect to x. All right, and last but not least, if we have some integral from a to b of f of x with respect to x, we can actually break that down. We can go the integral from a to some constant c of f of x with respect to x, plus we can pick up at that c, that same value, and go to b of f of x with respect to x. Okay, so instead of going right from a to b, we can go from a to c and then c to b. Or even if you wanted to, you can go to integral from a to c f of x with respect to x, plus the integral from c to d f of x with respect to x, plus the integral from d to b f of x with respect to x. So you can go from a to c, c to d, then d to b. But as long as you're going from a and end at b, you can do this as many times as necessary. But more times than not, 2 terms will be enough. But you can do as many as you want. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our first example. All right, so let's say, for example, what if we wanted to evaluate the integral from 0 to 1 of -6 f of t minus 4 times g of t with respect to t if we are given the integral from 0 to 1 of f of t with respect to t is equal to 5, and the integral from 0 to 1 of g of t with respect to t is equal to 8. Okay, so with this one, I'm just going to go ahead and rewrite that. Okay, so you have the integral from 0 to 1, negative 6 f of t minus 4 g of t with respect to t. All right, so first thing we're going to do is we're going to distribute our integral. So we can distribute that integral to both of those terms. So that will give us the integral from 0 to 1 of negative 6 f of t with respect to t minus the integral from 0 to 1 of 4 times g of t with respect to t. Okay, so now we have a constant in front of our functions, so we can get those constants and just pull them right out to the front. Okay, so that's going to equal negative 6 times the integral from 0 to 1 of f of t with respect to t minus, we're going to bring that 4 out to the front, times the integral from 0 to 1 g of t with respect to t. All right, so we know here that the integral from 0 to 1 of f of t is equal to 5. Okay, so we have negative 6 times 5 minus 4 times the integral from 0 to 1 of g of t is equal to 8. So 4 times 8. Okay, so that's going to equal negative 6 times 5 is negative 30 minus 4 times 8, which is 32, which gives us negative 62. All right, so that one was somewhat straightforward. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Whoops. Okay, so let's say for this example, if we are given that the integral from 1 to 26 of f of t with respect to t is equal to 1, and the integral from 3 to 26 of f of t with respect to t is equal to 10, we want to find the integral from 1 to 3 f of t with respect to t. Okay, now for this one, you want to remember that the integral from a to b of f of t with respect to t is equal to the integral from a to some value in between of f of t plus that value, what we'll call c, to our b of f of t with respect to t. Okay. All right, so just using what we have up here, we can see that our integral from 1 to 26 of f of t with respect to t is equal to the integral from 1 to 3 of f of t with respect to t, plus the integral from 3 all the way up to 26 of f of t with respect to t. Okay, so that gives us something to start with. All right, so we know that the integral from 1 to 26 is equal to 1. So that means the integral from 1 to 26, that's 1, is equal to the integral from 1 to 3. We don't know that one yet, so we're just going to write that down. The integral from 1 to 3 of f of t with respect to t, plus the integral from 3 to 26, we know that's equal to 10. So this is equal to 10. Okay, so if we go ahead and just subtract 10 from both sides of the equal sign, these two cancel out. So 1 minus 10 is negative 9. So you have negative 9 is equal to the integral from 1 to 3 of f of t with respect to t, which is our answer, since that's what we were looking for. All right. So if you are still writing this one, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so what if we wanted to evaluate the integral from p to 4 of f of x with respect to x if we are given the integral from 4 to 11 of f of x with respect to x equals negative 6. Clean up that 6. There we go. And the integral from 11 to p of f of x with respect to x is equal to 5. Okay, so for this one, there are two things we want to remember that we'll need for this one. Okay, so you want to remember that the integral from a to b of f of x dx is equal to the negative, and we can switch those two around, the integral from b to a f of x with respect to x. Okay, and the integral from a to b of f of x with respect to x is equal to the integral from a to c of f of x with respect to x plus the integral from c to b of f of x with respect to x. Okay, so for this one, these are the two properties that we're going to need. All right, so go ahead and separate that just a little bit. Now, first thing we're going to do is look at the integral from p to 4 of f of x with respect to x. Okay, and we're going to apply this theorem to it. This property to it. Okay, so that's going to equal the negative, and we switch those two. So instead of p to 4, it's from 4 to p of f of x with respect to x. All right, now what else do we know? Well, we know that from 4 to p, we can break that down. We can go from 4 to some number and from some number to p. So what we're going to do is just kind of move that over a little bit. This is now going to be negative. So we're going to go the integral from 4 to 11 of f of x with respect to x plus the integral from 11 to p f of x with respect to x. Okay, so all we did, instead of going from 4 to p, we went from 4 to 11, then 11 to p. Okay, so that's going to equal the negative. We know the integral from 4 to 11, that's equal to negative 6. Okay, so you have negative 6 plus, and we know our integral from 11 to p, that's equal to 5. Okay, so that's going to equal negative 6 plus 5 is negative 1. Negative times negative 1 is just 1. Okay, so we know as long as our a is less than or equal to x and less than or equal to b, or our x is between a and b, this will be true. Okay, so in this case, we're going from 4 to 11, then 11 to p. So in this case, our p would have to be larger than 11. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and do one more example. Okay, so let's say, for example, you are given that the integral from 0 to 10 of f of x with respect to x is equal to negative 4. We also know that the integral from 0 to 1 of f of x with respect to x is equal to negative 3. The integral from 0 to 10 of g of x with respect to x is equal to 5. And the integral from 0, let me clean that 0 up, from 0 to 1 of g of x with respect to x is equal to negative 5. Okay, and we want to find the integral from 0 to 10 f of x minus 3 g of x with respect to x. All right, so what I want you to do is I want you to press pause, and I want you to solve this, or give it a try solving that one on your own. All right, so assuming you've pressed pause and worked this one out, let's go ahead and verify your answer. Okay, and there's a reason I gave this one to you to try and solve on your own. Okay, so if we have what we have here, we can go ahead and distribute our integral here. So we have the integral from 0 to 10 of f of x with respect to x minus the integral from 0 to 10 of 3 g of x with respect to x. All right. Well, with this one, we could have brought our constant out to the front, but I chose to do that as a separate step. So that's going to equal the integral from 0 to 10 of f of x with respect to x minus 3 times the integral from 0 to 10 of g of x with respect to x. Okay, so we know that our integral from 0 to 10 of f of x is equal to negative 4. Okay, so that's going to equal negative 4 minus 3, and the integral from 0 to 10 of g of x, okay, we see that's equal to 5. Okay, which is negative 19. Okay, now the reason I gave you this one is because even though we have all of these different given values, we did not use them all. We didn't use this one, and we did not use this one. Okay, so just because they give you 4 or 5 given values doesn't always, even if they gave you 3, they may give you more than what you absolutely have to use. And in this case, we did not have to use those 2. So just because they give you the value of an integral doesn't mean that you have to use that value. Okay, in this case, we only needed those 2. Okay, so hopefully this made sense, and I will see you on the next video.